Good morning, everyone. I'm Michael Hunnell, and I'm the Director of Business Development for Metamagnetics. Today, my tech talk is going to be about ultra-wide bandwidth receiver interference protection. That sounds like a mouthful, but really all we are trying to do is help keep communication systems operational in the presence of high-power interfering signals that would typically jam or damage the system's radio. This is, of course, a growing problem across the DoD, since more and more wireless sensing systems are being used in military applications. Along with this adoption of technology, end users are pushing for broader operational bandwidth, which gives these users more freedom of communication. However, with wider bandwidth, these systems are now exposed to a wider array of interfering signals. And so, as I'll explain, our technology can help. With that, we can dive right in. So what makes Metamagnetics so special? Well, we at Metamagnetics are building devices and technology from the ground up, literally. So we specialize in magnetic material design. And by basically starting with the basic magnetic material, we're allowed to create novel performance characteristics which allow us to design these higher level components and systems. And so our specialty is obviously a lot of the comms, RF, microwave, millimeter wave type area of focus. Because we make everything ourselves, we can design and prototype very fast. As we said, we control the materials ourselves. And so our auto-tune filter, you may or may not have heard, is kind of our flagship solution. But that's not all of who we are. We also offer magnetic circulators. In other words, they don't require a biasing magnet, and these are common components in transmit and receive modules. In fact, they're 90% smaller than their traditional counterpart. And we even offer high-power microwave solutions with our nonlinear transmission lines. So these RF sources are not only smaller than the traditional high-power microwave source, but it's also tunable, which is extremely unique in that field. And so with that, let's talk about the main product of focus today. So the goal or challenge of our SBIR was to help out electronic support measures on UAVs. Now, these systems are typically pretty broadband, so I would say 2 to 18 gigahertz is pretty common, if not even wider. And what they're really designed to do is listen to just everything that's out there and take it in. So you want to be able to listen to low-powered desired signals that are all the way down in the noise floor, but at the same time, you want to be able to still operate even though you have all these high-powered signals that may be coming in at various parts of the operating band. Now, to complicate the matter even more, UAVs typically are small and they don't have a lot of room, which means these systems don't have a lot of room to design countermeasures to kind of mitigate these high-powered interfering signals. And so that's what our technology comes in, and I'll explain a little bit more on the next slide. When we talk about the ability to hear small, weak signals while simultaneously dealing with large, high-powered signals, we're essentially talking about the dynamic range of the radio/receiver. When the difference in power levels between the small signal and large signal is greater than the dynamic range of the radio, the system is essentially jammed. So when the high-powered signals hit the front end of a receiver and it is beyond the dynamic range of that receiver, the operator has to, in an attempt to protect his system or dig out the small signal of interest, will turn on his automatic gain control, or AGC. We can see this play out in the figures on the left and center of the slides in front of us. With the AGC turned on, the large signal is brought down to a manageable power level, but in doing so, we sacrifice the sensitivity of the system, and therefore we can no longer hear or receive the small signal of interest. However, here the auto-tune filter provides the solution. By only reducing the power of the high-powered signal at its exact frequency, we no longer sacrifice the sensitivity of the rest of the system, and therefore the small signal can still be received. Well, how does the auto-tune filter or ATF do this? Well, essentially, it's a
passive device that's able to selectively reduce high-powered signals at the exact frequency they're interfering with. Now, this is important because it doesn't just reduce the entire sensitivity of the system, like, say, a limiter or other types of automatic gain control. What it does is it basically sets up a power level or power threshold that no one signal can surpass. And so this threshold is typically where if a signal went above it, your entire system would start to experience issues. So when we do see a signal go above it, like when we look at the graph or image on the far left of this slide, we get what we call a notching response, which is what we see now on the center image. So basically what happens, wherever there's a high-powered signal that exceeds that threshold, the device responds with an equal notching response at that exact frequency. So what is the outcome of all this? Well, when we look at the image on the right, we basically get a leveling of our output spectrum. In other words, the signals that were above the threshold were all reduced back to that threshold. But what you'll notice is the signals that weren't above that threshold and were in other parts of the spectrum didn't receive any additional attenuation. In other words, they weren't reduced any, unlike the other high-powered signals that we're looking at. And so this is critical because this allows us to basically handle these high-powered signals, reduce them, but at the same time, we're not losing our sensitivity and our ability to listen to these low-power signals. And what you'll also notice is that one device is able to handle multiple signals. So this is very different than, say, like a filter, where you can only respond to one interferer with one notching filter. The auditing filter is not limited to the number of signals it can deal with. Now this is great. We have the solution. We can cover a broad bandwidth. We're able to keep these high-powered interferers at bay. And we can also listen to our low-powered desired signals of interest at the same time. So where is this great technology as far as TRL, development, etc.? Well, we've actually already proven a proof of concept. We've done a 2 to 18 gigahertz device. Now, the big change is, as we take that initial prototype, we are now delivering it to the customer to work on fully integrating this into the subassembly of the ESM system. And so we're working diligently with the Triton team and modifying the performance specifications to make sure that the ATF is perfectly balanced with all the other parts in the system. And so we hope to have that completed by the end of this program around 2022. Now, for those looking beyond the Triton program and saying, does this system fit for me? Here's a quick overview of some of the key features and advantages of the auto-tune filter. For one, as we talked about, it provides protection from high-powered Cosite and jamming signals. Very high power, several tens of dB above the threshold is not uncommon. Now, this is important because it not only helps allow ESM receivers to operate, but it can also act like a limiter and flat out just protect the system in the event of a high power attack. Other advantages is it allows the detection of the low level signals even when these high power signals are present, which again is critically different than traditional options. Usually when you get a lot of these high powered Cosite, high powered jamming scenarios, the user has to choose whether he wants to have his communication link open or if he wants to be able to deal with these kind of interfering signals. And then finally, the device is passive. There's no digital components. There's no additional power required. You literally just place this in the receive chain, behind the antenna, or behind the LNA, in front of the LNA, wherever you feel you need to protect, and the device is just automatically on, automatically ready to protect your system. And so the table below basically gives you a little bit comparison of some of the other devices out there. Again, what's really unique about this device is it's not like just a limiter or a filter. It's kind of both. You know, it doesn't require any sensing, just like a limiter, but it gives this filtering effect like a traditional notch filter, and it's not limited to the number of signals again. So when we look at something like the auto-tune filter, it's truly a revolutionary way to deal with these types of interferences in your system. Now, in the short term, as I mentioned, we're working diligently with the Triton team, specifically on their ZPY9 radar system. That being said, the technology is clearly not limited to that one application alone. It can be applied to a myriad of other systems, applications across all the DoD entities. Now, in the short term, beyond the Triton team, we can look at things like ZPY3, the MIDS, other receiver systems that are already on that aircraft. But that's not nearly the end of the kind of the scope of what this can be applied to. We're looking all across the DoD, as I mentioned. And so we're looking at other airborne aircraft, as I mentioned, like the ALQ-210 ESM system on the MH-60. But, you know, now we're talking, what about ground jamming EW systems? So we're looking at Duke, Crew, handheld radios, which is not listed on the slide. We're looking at the BATS-D, PRC-117, GPS. If there is interference that you're trying to mitigate, while also trying to keep your communication line open, then we're your solution. Now that we've talked about how great the product is and all these wonderful transitions, the big question becomes, how the heck are we going to get this into the warfighter's hands? Well, as I mentioned at the very beginning of the presentations, Metamagnetics makes their own materials. And so we plan on selling directly to the consumer and making it ourselves. And the reason being, well, it's a material solution. And so from an IP stance, it's in our best interest to protect that and keep it in-house. Now, that being said, we're probably not going to sell a component to, say, a Lockheed Martin or a Northrop Grumman and just say, all right, put this on your board and you'll be good to go. We're probably going to have to work with level 2, level 3 suppliers and kind of fit this into the subsystem, which is absolutely fine. We do this now with all our other parts, and we'll continue to do that, and we have happy working relationships with many of the primes out there today. That being said, we are working alternatively on retrofit solutions that we could sell to, say, directly to the Army, Navy, Air Force, what have you, that they can put directly into their systems on their own. And so by having kind of a mix of this model, we try to cover all ends of the sales channel. And so thank you for listening to my Tech Talk presentation. Again, I'm Michael Hunnewell. I'm the Director of Business Development at Metamagnetics. If you have any questions about the auto-tune filters, this presentation, or really any of our other product offerings, feel free to contact me. I'll be manning the virtual booth, of course. And again, thank you for taking the time to listen to my presentation. Please have a good day.